Hello, everybody, and Happy New Year. I am so excited to actually be able to teach you all still, even though I'm not physically there. I'm recovering and I will be back in a few weeks. So I just want to let you know that you are still 100% responsible for all of the work that we have to do. Everything that's posted to Google Classroom, I will begin putting in your grades. So, yeah, happy, happy, everybody. All right, so we're going to go ahead and get started. All right, the first thing is I want everybody to turn to page 225. We are actually on lesson 10, which is solve linear equations with one variable. Um, in this uh, in this particular lesson, we're actually solving equations with variables on both sides. And remember, the whole goal is to have the variable on one side and the constants on the other. We all know that variables are letters and constants are numbers. All right, so everybody should be at page 225 in their books. And basically, the problem that you have is the 1/2 and inside parentheses, which is called quantity 3x minus 1 equals 1/4 times the quantity x plus 3. We're actually trying to solve this problem, but the first thing I want you to recognize is that we have two fractions. And most students think that fractions are evil, they're not our friends, but fractions are your friends. So we're going to try to get rid of the fractions first because that's, in my opinion, students are more successful when they solve it that way. So the two fractions in the problems are 1/2 and 1/4. So we're going to look at only the denominator because we want to find the least common denominator. Okay, so we look at the number 2 and the number 4. All right, we want to list all the multiples of 2, which is 2 times 1 is 2, 2 times 2 is 4, 4 times 3 is 6. So then we want to list the multiples of 4. 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. So once you list the multiples, you look at the number that they both have in common. That's the smallest. The number that they both have in common is 4. Okay. So if you can see here, they have already used 4 as the least common denominator. So they're multiplying both of the fractions by 4 to get rid of the fraction. That's the whole goal. Okay. So if we place this 4 over 1 and multiply it times 1/2, okay, you multiply across. So 4 times 1 is 4, 1 times 2 is 2, and 2 divides into 4 only 2 times with no remainder. Okay. So this is how they get this number 2 on the outside. Okay. So they want to do the same thing, all right, but with the 4. If I know I have 4 and I place that over 1 and I multiply by 1/4, I get 4 over 4, which equals 1, which is how they get this number here. All right. So what I want you to do now is we want to now apply the distributive property. All right. So let me get rid of this on my screen. All right. So we want to apply the distributive property. So to apply the distributive property, remember we are multiplying whatever numbers on the outside of the parentheses by each term inside the parentheses. Okay. I don't know why it's taking so long to erase, but hey, that's what it is. Now remember, you can feel free to pause the video if I erased it too fast. Pause the video to make sure you have all your notes. All right. So now we're going to distribute this 2. So that means we're going to multiply 2 times 3x, which is 6x. We multiply the coefficient. The coefficient is the number in front of the variable. So the number in front of this variable is 3. So you multiply 2 times 3, you get this 6 right here. Okay, and you leave the x by itself. Then you multiply 2 times 1, which is 2. And all we do now is just bring down the subtraction sign. Okay, so we just brought that down. No extra work, okay? Then you multiply 1 times x. 1 times x is x. And then you multiply 1 times 3, which is 3. Okay? So now that we distribute both of those, we now want to combine like terms. Remember, we want the variable on one side and the constant on the other. They did it all in one step. So I'm going to show it on the side where we're looking at it in two steps. So we have 6x minus 2 equals x plus 3. Okay. So now all we want to do is bring our variables to one side and our constants to the other. So I'm going to draw a little line down the middle here. And I'm going to label this V for variable and C for constant. Now, if we see, we have 6 variables on the left, 1 variable on the right. So it makes more sense to move the variable x to the other side. So we're going to subtract x on both sides. So that gives us 5x. So on the other side, we have a constant left over because, when we subtract it, that goes away now. It cancels out. Okay. We want to bring this constant, this minus 2 on the other side. So we're going to add 2 to both sides. So we add 2, this cancels, and on this side we have 5. So that's how they got this answer down here. 5x equals 5. So how did we get 1? We're going to divide both sides by the coefficient 5 and let x equal 1. All right. So we're going to stick with the first way. That's the way I want you to master. But I'm just going to talk about the second way so you know how they got that answer. Just in case you want to use it and you're really good at working out fractions, then feel free to go ahead and use it and be awesome with it. All right. So let me go ahead and scroll down so you can see the second problem. Okay. So it says another way to use the distributive property is to multiply 1/2 and 1/4 first. Okay. So basically all he did was apply the distributive property, distributing this 1/2 times that 3x and that 1/2 times the minus 1, which is how they got that second line. And then next you have 1/4 times x and 1/4 times 3. Well, this problem, the way this is working, that you are multiplying fractions the entire problem. And most students don't like to do that. So it does not give you a wrong answer. If you notice, the answer that they got is still 1, which is the answer we got from the beginning. Okay. So when you distribute, just show you real quickly, when they distribute that 1/2 times 3x, we place that 3 over 1 and we multiply across. 1 times 3 is 3. 2 times 1 is 2. And then the x just follows. This is how they got 3/2 x. Okay. And then the 1/4 x, same thing. They multiply 1/4 times x, 1/4 times x, place the x over 1, and then you have 1/4 times x. Okay. It's the same thing as saying x over 4. Okay. But we know that in front of this x is an invisible 1. So we just say 1/4 x. Okay. So either way is correct. I'd rather see this 1/4 x. Okay. So at the bottom of this problem, in order to get x by itself, they had to multiply both sides by the reciprocal. Both sides by the reciprocal. Okay. So in order to get rid of 5 over 4, you have to multiply both sides by 4 over 5, which is the reciprocal. So let's get rid of this here so I can show you. Alrighty, this is the erasers taking forever. All right, here we go. Okay, so if I multiply 5 over 4 by the reciprocal, 4 over 5, Thank you. I know y'all saying bless me. I appreciate it. It gives me 20 over 20, which equals 1. Okay. So this is how they get x equals 1, because they're multiplying both sides by the reciprocal. Okay. So on one side, you're going to have x, and on the other side, you're going to have 1. All right. So that's just an introduction to this, so you know what we're about to start learning. So what I want you to do now is I want you to turn to page 226, which is the next page. All right. It says thinking about linear equations in one variable. Do this activity together. So that's what we're about to do. And we're about to investigate linear equations. Remember, linear equations are equations that form a line. And linear equations can be useful in modeling situations where there is an unknown value, such as in the problem below. It says you buy 6 notebooks. So you have 6 notebooks and a set of 2 pencils. And means plus. Okay. So we bought 6 notebooks and $2 set of pencils. Then it said a friend buy 4 notebooks and so plus $8 set of pencils. It says how much does one notebook cost? How much does one notebook cost? That is the unknown. Anytime you read a question and you don't know what it is, it's the unknown. So that means for each of the notebooks, we can say let notebook is the cost of the variable. So we're going to say let X equal notebooks. So X equal the number of notebooks, okay? So you can see that that problem was translated to 6X plus 2 equals 4X plus 8. Why do we have them equal to each other? Because it said they paid the same amount of money, okay? So whatever I paid for 6 notebooks and a set of 2 pencils is the same amount the person who bought 4 notebooks and 8 sets of pencils for. It costs the same. Okay. So we want to find the cost of one notebook in this case. All right. So I'm going to work this one out here. Okay. So we want the variables on one side and the constants on the other. So we want to bring our variables on one side. Remember, you look at the larger variable. So in this case, 6X is on this side. So I'm going to go ahead and subtract 4X from both sides. I'm going to take away 4X from this side and 4X from over here. When I do that, that cancels out and I'm left with 2X over here and plus 2. And this equals 8 over here. Now this is 2X plus 2. I'm going to subtract 2 from both sides. And now I'm left with 2X equals 6. Dividing both sides by 2. X equals 3, which is how they got the cost for $3. Okay. So the whole goal is to have variables on one side, constants on the other. So let's look at problem 1. Problem 1 was already given to you, was already set up. And what I want you to do here, I want you to try to solve it on your own. So I want you to go ahead and pause this video. It says in store A, you can buy 3 notebooks and a set of 2 pencils for the same price as 4 notebooks. They've already set it up, but they want you to solve for X. So I want you to pause it, solve for X, and then come back and watch my explanation and see if you got the right answer. So I'm going to give you a time to pause it right now and work it on your own. All right, so now that you've unpaused the video, we're going to go ahead and go over the answer. I don't want you sitting and just copying. I want you to get a chance to actually work it out to see if you actually know what you're doing. So we're going to have this problem here, 3X plus 2 equals 4X. Remember, we want the variables on one side, the constants on the other. So I have my larger variable on that side. On the right side, it says 4X. So I'm going to subtract 3X from both sides. When I do that, this cancels, and I'm left with 2 equals 1X. I know that 1X equals 1 times X, which just equals X. Therefore, 2 equals X. So the cost of one notebook is $2. Cost of one notebook is $2. Okay. Let's look at problem number 2. Problem number 2 says in store B, you can buy 2 notebooks and a set of 11 pencils for the same price as 4 notebooks and a $3 set of pencils. How much does a notebook cost at store B? Pause the video and go ahead and work it out on your own. All right, now that you've paused the video, let's go ahead and work it out. We have 2x plus 11 equals 4x plus 3. All right, we want to subtract 3 on both sides because my larger constant is over here. This cancels, and I'm left with 2x plus 8 equals 4. And then that's 4x. And then I want to subtract my variables, bring that to the same side. This cancels, and I'm left with 8 equals 2x. The coefficient in this case is 2, so we can divide both sides by 2. X equals 4. So the cost of the notebook is $4. Okay. All right. I hope you understand that. And if you have any questions, please let me know. You can post it in the Google Classroom. I'll be sure to answer any of your questions. You can also send me a video question and I'll send it back to you. Right now, I want you to turn to page 227 and let's get into it. It said previously you learned how to solve one variable equations. In this lesson, you will learn about solving one variable equations that include fractions, decimals, and variables on both sides of the equation, and the use of the distributed property, some things that we've already talked about. Use what you know to solve the problem below. Say Teresa is going with her family to watch professional barrel racers. Her family buys 6 tickets. They have a coupon for $1.50 off each ticket. They pay $52.50 altogether for their tickets. Write an equation that you can use to represent the situation and what is the price of the ticket before using a coupon. All right, so first of all, you got to think real life here. So Teresa's going with her family to watch, bell races, whatever that is. But they're going to watch a race. All right. They buy 6 tickets. If they have a coupon that's $1.50 off, is that a positive number or a negative number? Think about it. You should have said a negative number because if I have a coupon, it means I'm removing money, I'm saving money from the original price. So that's supposed to be a minus 150. Okay. So the key word in there was coupon, and that lets you know that it's a subtraction. So it's a subtracted 150. Okay. It says a family buys 6 tickets, and it says $1.50 off each ticket. So we don't know how much the ticket is. So the ticket is X. It say they pay $52.50 altogether. So altogether is the total. So total means equal. So if we have to write an equation, we have to put all this stuff together. All right. Because it says, what is the price of the ticket? So that means X again is the ticket. So we're looking for X. So we're going to say, let X equal the cost of the ticket. So let X equal the original ticket price. Y'all don't talk about my handwriting, y'all write with my finger. Okay? All right. So I bought a little fancy little pen. That junk didn't even work. So anyway, still got to make it happen, honey. So we want to set up this equation. So if they family buys 6 tickets, that means you have a total of 6. And they have a coupon for $1.50 off each ticket. So the ticket is X, and we're taking $1.50 off each ticket. And all together, they pay $52.50. Okay. Now I want you to pause this video and try to solve this problem on your own, and then come back and see if you got the right answer. All right, now that you solved it on your own, let's go ahead and check your work. So you do the distributed property. So you have 6 times x equals 6, not equal, minus 6 times 150, $1.50, and have that equal $52.50. When you multiply 6x, they give you 6 times x is 6x minus $9 equals 52.50. Now remember, we have our variable on one side. We want to bring that constant, which is 9, on the other side. So we're going to add 9 to both sides because it's already subtracted, and we want to do the inverse on both sides. That cancels and leave me with 6x equals 61.50. Divide both sides by the coefficient 6. X equals $10.25. Okay. So go back to the top, which is our original question. It says, what is the cost of the ticket before using a coupon? So before using a coupon, it was $10.25. Okay. So that's before the coupon is what they're asking for. Okay. Any questions there? So I will want you to write that in a complete sentence. I don't have any room, but you should be writing the price of the ticket before the coupon is $10.25. I don't know if I can type it in there. Let's see. Yeah. There we go. Hold on. The price of wide spacing. Baby. There we go. The price of the ticket before the coupon is $10.25. I want you to begin writing all your answers in complete sentences. We are absolutely too close to LEAP to not have that done. All right. So go ahead and move this text box down. All right. So that I want your final answer written in a complete sentence. All right. All right, good to go, guys. Turn to page 228. Turn to page 228. And it said, look back at the price of the ticket before using a coupon. What equation did you write? Explain what each part of the equation represents. All right, so we had the equation. We had 6 times the quantity, x minus 150. All right, and then we had that equal to $52.50. All right, so the 6, what did the 6 represent? The number of tickets. So 6 equals the number of tickets because they bought 6 tickets. They clearly said that in the problem. Okay. So 6 equals the number of tickets. What else do we have? We had the $1.50. We had X, right? X was the cost of one ticket. What else do we have? The 150. All right, so we have subtracted 150. That was the coupon. We got to know what the paucities equation mean. And the last part that we didn't have shown was $52.50, which is a total paid for all 6 tickets. So the total paid for all 6 tickets. I have no idea why my computer is going so slow, but I hope you all can write all this down with me. All right? Perfect. So ask you, what does that mean and what does it represent? And there you go. All right. Then it says, look ahead. A linear equation in one variable can be written in a form of ax plus b equals c, where b and c can be any numbers and a can be any number except 0. Okay. Because if you multiply a and it's 0, if you multiply it times x, that means you're just going to have b equals c. All right. You don't want that. All right. So what I want you to do is I want you to attempt numbers 2, A, B, C, D, and E, and do number 3. Okay. And pause it and then come back when you're done and check your work. Okay. All right. Now that you have solved these problems, and we're going to go ahead and check this work right here. All right, so try to write small as I can. I don't know if I'll be able to do that. So it's explain why A is a linear equation in one variable. Okay, so if we distribute this 4 to the x and to the 2 and 1/10, we're going to get 4x minus 8.4 equals 7.2. Okay. When we do that, it is written in the form of ax plus b equals c. Okay, that look like a 9 and make that look like a A. Okay, ax plus b equals c. So if you can write any equation in the form of ax plus b equals c, then you have a linear equation, okay, with one variable. Now, even though it says plus b, remember when you have a minus sign in front of a positive number, that still can be written as, and I can write it here, 4x plus a negative 8 4/10 equals 7.2. Okay, it's kind of raunchy with my finger. So let's see, equals 7.2. All right, so if you can write it in the form of ax plus b equals c, then you have a linear equation. All right. So it says B, the solution of a one variable equation is the value of the variable that makes the equation true. So in this problem for B, they're asking you to solve for X. So if you did not get the correct answer for A above, pause it, work it out, solve for X, then come back to the video and let's see if you got the right answer. Do not just sit and copy all this worked out, okay?